Quantum communication promises to deliver secure communication networks, but how close are we to make quantum internet a reality? And what changes lie ahead? On Tuesday, January 21st, 2025, Optica is organizing an online industry meeting. This time, our speakers will explore the real-world challenges for tomorrow's quantum communication networks. As quantum computers get closer to deployment, the clock is ticking for industries to adopt post-quantum cryptography or PQC today and quantum key distribution or QKD tomorrow. Next generation encryption is needed to safeguard sensitive data against the threat of quantum computing enabled attacks. But while PQC holds a promise, a truly functional quantum internet requires more than encryption. It relies on innovations like quantum repeaters and quantum memories to store qubits and synchronize network operations. Think of it as enabling teleportation of quantum information. Despite progress, like achieving a remarkable 120 picosecond quantum memory by Optica corporate member QNect, we're still facing critical challenges. And as well as technical issues, geopolitics is playing a significant role in the adoption of quantum key distribution. While Europe is moving forward confidently, security concerns in the US are sparking debates around implementation and regulation. In our live interactive session, we'll hear from Nokia, Airbus, and British Telecom. They are at the forefront of tackling the quantum communication issues. As usual, our members will interact live with them and propose their technology as a solution. Companies such as ThinkQuantum, Aegiq, QTI, and KPMG will be there. Now let's go live. Today we have one of the topics that we enjoy the most. We have quantum key distribution, quantum communication. And with us, we had the entire supply chain of quantum communication networks, all the way to the end users. It is a great day, and I would like to thank, of course, all the supporters of Optica for making this event happen. I would like to start by letting all of you know that this is a different kind of meeting to the ones that you are used to. So this is an event in which you are here to participate actively. So we want to know from all of you in the room, we want to know what you do for others and what others do for you. This is an interactive meeting. I would like to start by saying that this couldn't be possible at all if it wasn't for our sponsors today. First of all, OptiWave. OptiWave provides a platform for design and simulation of optical links, photonic devices. They have the Opti system, Opti LTD, Opti Spice, and Opti Instrument. All the platform possible there to design and simulate optical instrumentation. I also would like to thank, of course, coming from the QKD success stories in the world, ThinkQuantum. Well, they have a new product, the QKY, Q-U-K-Y. And this product provides BB84-based quantum-safe cryptography. All of them already ready, commercially available. This is a real product that you can purchase and test for the first time, QRM2 qubit direct streaming. Thank you very much, ThinkQuantum, for being with us today. This is how it works. We have two sets of companies. On one hand, we have the integrators, companies who came here looking for partners, looking for companies who can help them solve challenges. We have Nokia, KPMG for the first time as an Optica meeting. Thank you very much, KPMG, for your support. British Telecom with their partner Aegiq, Airbus, European Space Agency, and the giant Honeywell. These are the companies who come here looking for partners. And of course, we have our members with solutions to supply the partners. We have all of you here, but some of you have contacted us and asked if they can show a slide. Those are ID Quantique, QTI, Quantopticon, memQ, and of course, ThinkQuantum. This is the rules of the game, but all of you should be active. Today we have an online industry meeting on quantum computing. In a couple of weeks, 11 February, biosensing. And all of you, please mark your calendar, 25th of February, photonic integrated circuit packaging. That one is going to be fascinating. All the agenda for online industry meetings is available until the beginning of February. If you want to participate in any of them, all you have to do is contact us and we'll make sure that you get the visibility that you deserve, and most important, that you get the partners that you need. But now, let's start. Let's start by saying that this is part of the corporate engagement program, and if you want to continue doing your job, please become a member. But now I would like to remind everyone that this event is at the same time live streaming YouTube. So let me say hello to the YouTubers for just a second. Hello, YouTubers of the world. You are following from the YouTube channel. If you have any comment, please write it so in the chat, and I will be more than happy to read it in the room. This is, of course, also valid for the people with me here in the Zoom room. People with me here in the Zoom room, if you have any question or comment, please write it in the chat, and the microphone will come to you so you can voice the question yourself. And with that said, I would like to first of all thank the Optica staff for the amazing job that they have done today. And of course, thank all the different companies who are here with us to tell us how we can work together. And the best way to start a meeting like this one is to start with a company that, because of different environment, acquisition, work they have done with everyone, they have positioned themselves as one of the most active Optica corporate members. I'm referring to Nokia. And to open the quantum communication online industry meeting today, I had the honor and pleasure to welcome the head of quantum safe networks at Nokia, Martin Charbonneau. Martin, thank you so much for being with us today. The floor and the attention of everyone is yours.
Thank you, Jose. Well, thank you very much to Optica for inviting Nokia to this event. I'm hoping you can see my chart. Can you see my chart? Yes?
Exactly.
Okay, perfect. So as you said, Jose, Martin Charbonneau, French-Canadian name. I'm the global head of Quantum Safe Network at Nokia. So it's quite a pleasure to open up this overall session that Optica has put forward with regards to the challenges and opportunities in quantum communication. I will focus really my narrative on quantum safe networks, but specifically securing our digital future starting today. So first, I wanted to just make sure that you recognize who we are, right? No, we're not making cell phone anymore, right? So Nokia does not make great cell phones, robust cell phones. We actually lead the transformation of where networks meets the cloud. Specifically in the context of the Nokia that I'm going to talk about today, we built a lot of technology, part of the group Nokia. A lot of the technologies that act, help the world act together, enterprises and service providers. But my focus today is think about the Nokia that builds and enables enterprise and service provider terrestrial and subsea networks. Think about the enabler of dynamic connectivity that supports massive requirements such as performance, cost, but also data and flight security. We operate in 130 countries. We're Finnish-based, so a lot of our presence and impact is throughout the world, but for sure in Europe, as you could imagine. But now when we focus on security, as said, Jose, in the introduction as well, I mean, the clock is ticking on traditional security. A lot of our audience knows this. We know that at one point in time, quantum computers will reach a level of stability, performance, and we'll be able to actually crack the codes that we've been using in the last 30 plus years to actually build our digital economy worldwide. So as the left-hand side picture shows, right, a rogue actor with a quantum computer at scale that can actually perform cryptographically relevant operations would be able to crack the cryptography that we're using today in our digital signatures construct, in our key encryption, on our cryptography encryption type of construct as well. We know this is a probability at this point in time. And on the right-hand side here at Nokia, we tend to look at different empirical data. One that I'm showing here today, coming from the Global Risk Institute report, got updated in December 2024. So we know that there's a 14 to 60% high probability of a quantum computer being able to actually crack codes within the window of 5 to 15 years. So what we're talking about is we need, as organization, enterprise organization, service provider organization, we need to understand our risks with regards to this mounting threat and actually seek mitigation techniques to reduce our risk posture. And our view here at Nokia is while you're doing that, you shall seek to mitigate, not in 10 years from now, not in 5 years from now. Some of our customers, mission critical type customers specifically, are actually seeking remediation to reduce their risk posture today, starting today. And as such, the industry has been driving a full-fledged migration in cryptography. So our view for this, right, we see a world, a quantum safe world that starts today that employs a defense in depth type of framework. I don't have time to go over the detail of this, but I'm just going to leave you with the high level framework for this. Consider on the left-hand side, we do have access, and we will have access on two formidable type of crypto system that can give us the ingredients to actually create a quantum safe world. The world of mathematics with the new algorithms called PQC for signatures and key exchange. The world of physics, classical physics, quantum physics, and you'll hear a lot from quantum physics key enablers today. Both two worlds give us the needed ingredients to create constructs where we could apply crypto techniques at the application level in black, but also we believe as network enabler for enterprises and carriers, we think that the network layers being IP networks, MPLS, Ethernet, or optical networks, OTN, can also play a complementary can also become complementary lines of defense in a defense in depth framework, complementing the application layers that will most likely use post-quantum cryptography algos. And then the blue layers will most likely use physics-based cryptography, be it QKD, pre-shared keys. And of course, there's going to be a blend of post-quantum cryptography meeting QKD or pre-shared keys. The point is we need to focus on securing our digital future with crypto agility and crypto resiliency. So here at Nokia, we actually offer solutions that are focusing on building optical networks or IP networks, the blue construct in my chart, enabling the world to connect in a quantum safe manner. We use keys that comes from the domains of mathematics, PKI, post-quantum cryptography, or physics, pre-shared keys and QKDs. And in our construct, we at Nokia, we are not building all of this alone. We build the blue, but when it comes to the red, QKD, PKI, PQC, we partner because together we go further. As an introduction, you heard that we're here as well to listen to, those who are actually moving in the technology realm as perhaps partners with Nokia to help us with technology integration, knowledge sharing, innovation pipeline. Together, we go further in quantum safe networks. And in closing, quantum safe networks is an outcome. It's an outcome that I believe the industry, as we continue our digital journey, shall seek at both the application and the network level by applying crypto techniques on classical networks today for enterprises, mission criticals, and service providers. But quantum safe network can be seen as a trusted bridge that helps the industry focus that this outcome to have quantum safe digital future is something that we will never lose, even when we research advanced quantum-based 2.0 technologies such as networking, computing, security, and sensing. So let's embrace together this digital future that is quantum safe. There's many techniques that you will see, many approaches, but your approach should be to understand your risk and strive to seek protect your future starting today with quantum safe connectivity. And we're here to help you on that context. Thank you very much for your attention.
Great. Thank you, Martin, for a great talk to open the meeting. I really like your message on this last slide about trust. Do you see this as a big hurdle to overcome, making different economies and stakeholders trust quantum technologies?
Well, absolutely, because when we lead the message like this, right, you may have noticed I've actually relegated technology to the back seat, right? So we as humans on this planet, if you look at how or dependent we are on our digital framework for our personal life, in our professional life, if we lose trust in the digital construct that we've put together, there's no plan B. There's no analog world waiting to be reactivated. So to me, having trust in the data integrity, authenticity, confidentiality today and for tomorrow, there is no substitute. So we as an industry have to understand that. We have to understand that there's actors out there that wants to create chaos, but what you'll see today, and if you seek how to reach quantum safe application and quantum safe networks, there's solutions. There's solutions today that you could start applying in your quantum safe journey and roadmap that helps you, continue having unshakable trust in the precious data artifact that we consume and produce every day.
Great, thanks for that. And being a true system integrator, are there any major pieces missing for you at the moment that sort of keep you up at night?
Yeah. So there's, and I think your introduction said it, right? So when it comes to being able to deploy at scale, at performance, the crypto system that is more physics oriented, like let's say quantum key distribution, quantum physics. I think we have great solutions today, and every day my colleagues in that field of the industry are actually pioneering and inventing and actually going further. But I think once we continue research on quantum repeaters, quantum memory, entanglement swapping, where really the act of communicating becomes by just the artifact of communicating, when you're quantum safe because of the quantum entanglement type practices. That's where we need to continue the research. We need to continue to push the envelope, ushering towards quantum-based technology and quantum communication. But meanwhile, we have to start integrating solutions today. And one of the barriers to all of this, solutions that exist, it's awareness. So a lot of our people on the planet are still largely unaware that we have to do significant migration in cryptography to secure our digital future starting today. So I would say yes to the technology, and I think our colleagues, many of us are doing great, marvelous innovation on the technology plan. But as a group, we have to make sure that we rally rest of the industry, decision makers, CISOs, C-suite type of decision makers, and different level of enterprises and carriers to understand that action needs to be taken today to secure our digital future.
Great, thanks, Martin. We do have a question in the chat here. So this is from Leon. Leon, would you like to ask your question live? You can unmute if you like.
Okay, sure, yes. Hi, Martin. Good presentation, thank you. But the question is, given all the limitations that QKD has, technical security limitations and regulatory limitations, no devices have been officially approved or certified. What use cases do you see will be good combining QKD with PQC?
Well, so first of all, Leon, that's a good question. Very good question. What you see in my presentation is, first, I'm trying to make everybody aware that we should seek the outcome of reaching quantum safe application and then quantum safe networks as a complement. In reaching this outcome, there's two macro crypto system that opens up, technology construct that we can apply. And no two networks are the same, right? So quantum safe network is an outcome that I see applied a lot nowadays in mission critical networks, specifically data center access, data center interconnect use cases. And in that context, there are some, deployments that makes a lot of sense by using pre-shared keys or quantum safe, QKDs. There's also, use cases in that construct that makes sense to use PQC at the application level, QKD at the networking level, and have a defense in depth type construct. So my answer to everybody, no two networks, and not even one network, is homogeneous, right? Everything is really heterogeneous. Seeking the outcome is the first focus. How to realize the outcome, it needs to be very curated, adapted to the reality of an infrastructure provider or a specific segment type enterprise customer, defense, BFSI, healthcare, and so on. And what specific use cases are we trying to really realize at this point in time? And once we pare down these types of use cases to something very precise, I've seen that some solutions makes a lot of sense, including quantum key distribution, but trying to apply everything to everything doesn't work. The outcome is everything to everything. How to realize the outcome is this adaptability and the ability to actually employ product and technology to realize the outcome applied to very specific use cases of very specific real life enterprises or carriers. So I don't know if you like my answer, but there's no one size fits all will be the last slogan I'll drop on you.
Great, thank you so much for the question and the answers. So at this point, I'd like to bring into the conversation two companies who will be crucial in facilitating market adoption of QKD systems by enabling cost-effective and faster migration to quantum-safe communications. Firstly, Simon Patkovich, Vice President of Quantum Safe Solutions at ID Quantique. Please tell us more about the enabling technology you can offer. So, Martin, if you can stop sharing, we can get Simon slider. Great. Simon, are you able to share?
Yes, I hope.
Great, yeah, it's coming. Great, we see your slide. Great, thank you.
Yes, super. And let me also just get the video going. I hope it will work. Yeah. Okay, so for the sake of very short time, we have here, I'm going to get going pretty quickly. So the two topics I would like to bring to everybody's attention, or the highlights from the past 12 to 18 months of work we have done, is something that closely aligns to what Martin has very eloquently described. And that is that the industries are looking to combine technologies, and we do not see these wars between PQC and QKD camps any longer. This particular concept that I'm showing here is based on the JP Morgan Chase's announcement of proceeding with a dual strategy in remedying or providing mitigation strategies for quantum threat, a risk from quantum threat, and they call it dual strategy, and leverages PQC on the application layer going down as appropriate depending on the level of risk and the urgency, and QKD technology from the bottom of the OSI stack. Networking people will know all about it, and then going up the layers, typically 1 to 3, but it can be extended further up. This is, I think, a significant milestone. It was announced last year at a couple of occasions, couple of events, and this is a depiction. However, this is not really possible without a huge ecosystem of partners, and Nokia being one of the most significant partners, at least for ID Quantique, enabling such interoperability that is standards-based, interoperability between different technologies. So that's very significant. And these are the companies that we have done work with to make sure this is, I'm going to use a cliche plug and play, but that this works simply and easily without any R&D needed on the customer end. It will just work. And then as the second topic that I would bring, because I understand I have 2 minutes, is this, and that goes back to the question that was posed to Martin, just and that is, well, QKD has limitations. To scale QKD, you have to use trusted nodes, which are based on software, physical trust, and there have not been so far any third-party formal evaluations. So I really want to stress this out, that this is so important, and this, in fact, is one of the major showstoppers for the technology to be more broadly adopted in the enterprise and government space. And ID Quantique has spent many years working with different standard bodies and national security agencies on this topic. And while there's so much work still ahead of us to get a harmonized international standards for such evaluations, and you have a couple of very interesting projects happening at the same time. That's work at DETSI, there's work at IDU, there's new Nostradamus program in Europe started on this. There are a couple of countries that could not afford to wait for all of this to happen at a pace that it's happening, and it's a relatively slow pace. It may take a couple of more years, and we've seen a fantastic activity in Singapore, in particular in Korea, and I would like to stress that this is, for us, it has been monumental to go through this, to see, and South Korea is a signatory to common criteria, as well as the producer of common criteria certificate, so they know what they're doing. They have about 5 agencies involved, and they have created, preempted all of this international work, and created their scheme for approval of QKD products, both from the optical post-processing as well as software components, which is very similar to FIPS. And we've been in this day in and day out full time for over 2 years working with them. It's been a lot of work, and I'm very pleased to say it's been going really well. And I would just urge everybody to watch our news channel. Have a very high level of confidence. There's going to be very good news coming out of it, and it's monumental for the whole QKD industry. We're not alone in the industry. You cannot have industry with one player. So it's very important for industry, for customers, for everybody looking at deploying dual strategy and deploying this multi-layer defense in depth approach. So I hope I have not overstepped my time boundary here, John.
No, that's great. Thank you, Simon. So with the that dual strategy approach of combining PQC and QKD seems to be a standard approach. Having heard the same from Andrew Shields just before Christmas from Toshiba Europe recently. So with the increasing number of companies offering sources of quantum safe cryptographic keys, I'm just wondering when you see the market really mass adopting these systems, and presumably when they do, it might be difficult to keep up the supply with the demand. Just wondering how you plan on addressing that.
Oh, that's a fantastic problem to have. I'm looking forward to it. It is, I would say, the last year and this year are a point of inflection, I would call them that way, for both QKD and just in general the physics-based quantum safe industry. As you know, our QRNG has been already FIPS approved, and it's an essential part of this solution, so QRNG, and now QKD needs to go through the same. And the question, the lower you are at the OSI stack, the fewer keys you need, the higher up you go. The protocols tend to be hungrier for keys, and there are a couple of technological ways to supply more keys. We do it at this point in time. We have a burst capability from the buffers, because QKD never sleeps, and even when you do not use a lot of keys, QKD is always manufacturing them and making them ready for burst use at a very, very high rate. But you're absolutely right. When this gets consumed by the TLS and an application stack, there's going to be need for even higher performance systems, and we're making these solutions ready and extending QKD beyond. There are many asks from customers. How do I put this on my vessel? How do I put this, over 1,000-mile distance over very poor optical network? How do I still get out of band key distribution from the same key management system? And we have just released a solution for that as well, which is QRNG based and hybrid cryptography based. So yes, there are solutions, and it's a fantastic question.
Great, thank you, Simon Patkovich of ID Quantique. So I want to bring in now Tommaso Occhipinti, co-founder and CEO of QTI SRL. Could you please tell us how QTI are providing products and expertise to enhance security mechanisms?
Thank you, John. Yes, I share my screen just for my only slide, so I promise I will be in the 2 minutes. Okay. We are Italian company, European one. We are based in Florence and Rome. We are almost 40 persons working in the field of quantum key distribution. So our products are all the key elements of making quantum key distributions real. So we have appliances and softwares to make this happen. As you have seen before with the previous presentations, the topic is very vast. It's important to say that it is crucial to have the key generators. So you see on the right side of my slide, we produce the quantum key distribution appliance. I mean, it has many good specification, but let's say that is a telco grade system, and it can be integrated into any existing optical network. For example, WDM networks, metropolitan area networks. I mean, any kind of this kind of systems. But you have to manage the keys that are produced by the quantum key distributions. So we also have an appliance that is called the QKME, which is essentially a manager of the keys, is working with all the standards that has been mentioned before. So we are also compatible with other vendors. We can work together with the upper layers and the lower layers of the OSI stack provided by other kind of companies. Lastly, as product line, we have also the possibility to insert into all our machines the capability of being controlled and orchestrated by the software-defined network. So following the relative ETSI standards. I would like to come back to the company just to say that yes, we are a company creating hardware machines, firmware, and software for quantum key distribution, but we have a great background on telecommunication, in the sense that we are part of the TIM group. TIM is the largest telecom operator in Italy, one of the largest in the world, and we are partnering when we have our mother company that is called Telsi, that is a well-known company working in the field of cryptographic machines. So we produce the keys. They can give also to the customers the cryptographic machines, the hardware machines to make crypto solutions. Finally, we are very, I would like to say that we are very open to collaborations. We are working also in a finance project by the EU and from other nations. So open to collaboration also on the research side. Here in the center of my slide, you see two examples of the big projects that we are following right now, but there are many other. So I'm here for possible collaboration, and I think this is the spirit also of Optica. Thank you.
Yeah, absolutely. Thanks, Tommaso. So related to my previous question to Simon on the supply and demand, what does the overall market look like for these systems? Will each business need their own system? Will we need them in our homes, for example?
Yeah. Our perspective is to start with the guys that really needs the super security at the beginning. So, for example, governmental applications, banks, financial application, these kind of guys require something that, I mean, starting from now, or let's say really soon. So this kind of market, let's say large spending, low volumes, we can say this. But then we will proceed with the medium, let's say other kind of companies that are more related to the security of their data, of their cloud data. And that in that case, the volumes will be absolutely very large. We have practical example of units sold to governments, to governmental national-wide networks implemented in this moment in Europe, as ID Quantique mentioned the very interesting results in Korea, in South Korea, and Singapore. We can say that also many nations in Europe have done something similar, and we are the provider of those kind of technologies, let's say. Hope to have answered.
Great, thanks, Tommaso. I just one more quick question. I chaired a panel in Network X in Paris in October around software-defined networks on current telecommunications infrastructure.
Yeah.
I'm just wondering, does your quantum software-defined network require any changes to this aging infrastructure?
It's a matter of being compatible with the orchestration, let's say, way of SDN, let's say, of standard software-defined network. So we can say that having a layer of software that is embedded in our appliances, we are, let's say, naturally compatible with the software-defined networks. Okay. I mean, this is the easy answer, let's say. Then everything complicates, as other previous friends said, that any network has its own specific characteristics, let's say. So, you have to see if, for example, there are optical switches in the between, if there are other kind of let's say hardware that must collaborate or communicate with us. But essentially, having this, let's say, layer software, we are in the right way to be integrated into SDN networks. Yeah.
Great. I believe there's a question from Richard Shannon. Richard, would you like to ask your question? No? Jose, do you see the question? I don't see in the chat.
The question is for Nokia, and Richard Shannon is here representing one of the investment capital groups. Actually, he's here from Craig-Hallum Capital Group. And his question is quite interesting and exciting. To what degree are photon-based quantum networks going to be rolled out over the next 2 years across physical telecom networks and satellites?
In the next 2 years?
Yes.
I'll let my quantum experts on the call answer. In the next 2 years, I think my personal view is going to be un poco, very, very, very small in the next 2 years, right? Satellites, and I think, we'll hear some from the satellite industry manufacturer and partners, but satellites will be up in the sky in the next 2 years, 2 to 3 years, perhaps. I think quantum physics, will, I said it, when I talk, we're seeing use cases where this is actually deployed, right? So you see some manufacturer on the call, you heard from both the QTI and Quantique so far, but we actually integrate and actually do not only do proof of concept and pilot networks, we do production networks. We have more than 100 networks already in service that are quantum computer safe with different techniques, not 100% QKD, not 100% pre-shared keys. There's a mix and match. But in the next 2 years, I think, to the precision of the question, I think it's going to be very, very small. We're still at the infancy of the deployments when it comes to satellite-based QKD and at reach, at scale QKD, but they are real life use cases, deployments of QKDs as we speak.
Thank you very much. I think Jon is trying to highlight the second keynote.
Great. Let me, it gives me great pleasure to introduce our second keynote speaker, Bent Gallagher. Bent is an equity partner and head of innovation and new tech at KPMG. Through this role and his position on the Danish Quantum Community's board of directors, Bent has a great overview of how the adopters of quantum communication feel about the technology and the urgency to adopt. So without further delay, from the UK to Denmark. Bent, the attention of everyone and the floor is yours.
Thank you. I hope that I'm able to turn the slides. Can you see the slide here? Role of quantum technology.
We don't see slides currently. We just see you.
Okay, you only see me. Okay, well then I need to share again. So here we go. Hopefully it works. Now you see me?
Yeah, we see the slides.
Okay, thank you. Oh yeah. I've been provided 6 minutes for this and had good discussion so far. Basically, I'm primarily here as being the global head of KPMG's Quantum Hub. Apart from naturally belonging to the Copenhagen office with great, you can say, quantum history as such. I mean, we started looking into quantum technology 6 years back, basically as the first sort of big four consulting company to do that. And we started with quantum key distribution. And actually, we did a display of Aegiq, Quantique, who is present here as well. And at that time, the technology was so big that we were not able to bring it into the meeting room. So we actually had to do the meeting in the atrium at the time. So it's a while ago. I will just quickly take you through, first of all, this threat that was talked about with Nokia. I want to make it very clear, this is really, if you're trying to break an RSA 1024 today with a normal PC, which is not what you do, but anyhow, it will take about 2 million years to do it. But when you have a capable quantum computer, this will take less than 2 minutes. And it doesn't make sense to go to a 2048 RSA, because it's actually not really the time to break it. It's the time to bring out the news of it being broken that takes time in this case. So it's about the same size and same time. So this is not the way to do it. And I just want to bring you this theorem. It's a very, very simple theorem by the physicist Mikhail Mosca, who made this because, as you might have heard before, hackers are able to download your data now. So they kind of harvest now and decrypt later. And he's brought this very simple equation saying, if you have X, which is the longevity of your data, this means how long are your data that must not come out to the public or to any kind of criminals or whatever. How long time does it have to be safe? And then you add the time it takes to move all your cryptography, at least 50% of your cryptography, to the new and safe cryptography. If you put those together, X plus Y, and this is longer than the time it takes for the quantum computer to arise that is able to use Shor's algorithm, then you are in trouble. So, and we see our clients having issues with this because they think, why should I do something now? Because there's no quantum computer that is able to break our data anyhow. But again, this is going to happen. And currently, I would say the year was most likely be around 2033. There's a little bit of discussion, whether it's 2030, 31, or whether it's 35. And also the Chinese application of quantum technology is a big issue here, because they are far ahead, especially in the quantum key distribution, where they have been active a long time. Already in 2019, they had 5,000 quantum secure internet, and they were also using satellites for QKD distribution already back then. And by the way, if you take the combined investments in the quantum technology in the world together, from states, from different nations, if you pull it all together, it's the same as the amount that China is investing in this. So please be very aware of this. And this was also what came to the now former President Joe Biden when he made his decree, basically his Preparedness Act, saying that all the important government institutions that had data needed to find a way to do a post-quantum cryptography. This was something they had 180 days to do, and we are still lacking the European countries to do the same. What we have from the CNSA, I mean, they have a timeline that is meaning a full change by 2033. Again, because this is where you can expect that the quantum computer most likely is going to be able to break this. We have been working with this, as I mentioned, for years, and initially we worked, Aegiq was a partner. We also partnered up with DTU, which is sort of the Danish version of MIT, if you will, and we made a QKD together with them, and then we tested this out commercially with the largest local bank, which is Danske Bank, which is second largest in the Nordics. And we actually were able to do real transactions through a QKD at that time. And we are involved in a number of different projects. Right now, we are working on the police project, which is coming to an end, which is really about different police organizations across EU, how we can use quantum technology to fight terrorism and organized crime. So that's one of the big things that is happening as we go. I think our role here is quite important, sort of from the ecosystem, because now we hear from providers and we hear about the people that can make the QKDs and so on. That's not what we do. What we are into is to tell the business that they have a problem, that they need QKD, they need PSK, they need to move into this space, and they need to do it quickly. First of all, what we are doing is that we are performing quantum risk assessments. So basically coming in, looking at the scope, looking at the data of longevity, having a number of workshops, and basically moving this into a risk where we look into the adverse effects of how we can mitigate the risk and summarize the findings we have, and especially introduce this perspective on data longevity. That a lot of times when we have this, they are saying data longevity. What do you mean? Are you talking about when we delete the data or what? No, I'm talking about how long time these data needs to be safe. And that can be a heck of a long time if you think about a pension company, a health company, some pharma companies, etc. So we are sort of the spearheading the front against C-level people to make them aware of this issue. All right. I mean, that's what I was going to say. I have a little Schrödinger cat here popping up.
Thank you very much for bringing the cat to the meeting. Most important, thank you very much for coming to a meeting like this one. Having KPMG before we had the intervention of also HSBC, having these firms telling us about how important for them quantum technologies are is making our day. So thank you. In my modest opinion, I am feeling that assuming that quantum computers are the risk and quantum key distribution is the solution, I think the risk is moving faster than the solution. How do you feel about this?
Well, I mean, it's. I think the biggest issue we have, and I'm also a co-founder of what is called the Danish quantum community, where we have been able to attract the attention of the government and also of businesses. And I think the biggest risk is that every time a company is being aware of this, they tend to ask the researchers. So they ask university professors, oh, when is this going to happen? And the researchers will always say, well, it's going to be 15 years from now. And they have said that for ages. And that is a big risk because in actuality, the quantum computer is, coming closer and closer to something useful. And already now, as was pointed out before, there are actually practical applications. And we expect also the IBM flagship computer to be not only for research use, but also for production use already next year. So I think this is the biggest risk. So it's not because the quantum computing industry is not moving, but the awareness of this is really not happening. Only the stock market is beginning to move, which is interesting.
I 100% agree with you. We have a lot of questions for you, Bent. The first one is coming actually from HSBC. Leon, for the second time intervening in the meeting, what's on your mind?
Well,
Leon
the question,
Volkanovski?
yes. Yeah. Hi, Ben. So the question you mentioned, was it Danske Bank that tested QKD? Was it some years ago, if I got it right?
Yes.
Do you know if they moved those systems into production? And if not, then why not?
No, they haven't done that yet. I think it's a little bit on the same It's the same plate of discussion we have. I mean, we also work with central banks right now on this same topic. They are a little bit more prone, but I think the issue is still the sort of the belief on, okay, when do we have a problem? And actually, when you look into cryptography, we always and already now have a lot of other problems that we need to solve. And I think that's one of the other risks, that is that there's so much going on in the crypto space that when you think about post-quantum, it's like, yeah, it's important, but not now. But it's really the wrong way of looking at it. Not to speak about quantum technology, by the way, and quantum computing, but I mean the safety of data is going to be a problem. And I'm sure that what we're looking into is like global heating. You know, I mean, we are seeing we know this is going to happen, and it happens gradually, but nobody sees it before it becomes a problem. And especially, I don't want to be biased, but just from political perspective, the Chinese, this is going to be so easy to go in that you don't even know that you have been in a system and out, because you basically have the key and you can just walk around, take whatever data and go out again, and nobody would know. It's highly dangerous.
We have a lot more questions. Thanks a lot, and thank you, Leon, for being with us today. Second one is from Alejandro Montblanc, also from HSBC. Alejandro, can you tell us what's on your mind?
Yes, thank you, Jose. Yes, I'm wondering, you know, many people, not only KPMG, right, but many people talk about harvest now, decrypt later, as a threat, right? As if something that was easy to do, something as if everybody was in immediate danger, right? But to the best of my knowledge, right, evidence of harvest now, decrypt later happening anywhere is scarce, to say the least, right? Or at least I don't know of any evidence online published anywhere, or anybody saying anything that has happened on harvest now, decrypt later, right? So I'm wondering, you know, harvest now, decrypt later is not easy to do, right? It's not straightforward. So I would like to ask you, what is, you know, what evidence do you know, if any, of these having happened?
Yeah, it hasn't happened because you can't do it. So the problem is that it is easy to harvest data. It's so easy that the last time I was visiting one of our partners in Israel that is doing cryptography and helping on that part, you know, he didn't even understand the question about whether he could break into a bank system. I mean, he didn't understand it. I mean, it was because it's something that he's always able to do. So the problem is not to steal the data. The problem now is to basically be able to read it, and nobody is able to do it right now because they're extremely well protected. But the problem is that you can do it and you can just keep the data. Nobody, you will have no cases because currently nobody is able to solve Shor's algorithm with any quantum computer. I mean, that is going to happen in the future. And the future being on the other side of 2030, most likely 2032 would be my guess if you ask for a date. But you know, if you have very long data, like health data, for instance, a pension company, maybe it's a pharma company with some recipes and whatever, it could be a bank with a lot of transactions by VIP people, then there's a problem.
Ben, you said 2026, so you are welcome to participate in the meeting we'll have next year, and you can tell us how it went. Next question is coming from the founder of memQ, Manish Singh. Manish, thank you very much for being with us. Can you voice the question yourself?
Absolutely. Thanks, Jose, and thanks for the presentation, Ben. The kind of risks that you alluded to, where I see the most impact in terms of financial loss is when there's a hacking attack or a ransomware attack, or the most infamous one, the more recent one, the Salt Typhoon one that happened, where all the telecom networks got hacked, call logs were retrieved. Are there any numbers or any sense of like if it can be mitigated using quantum technologies?
Yes, I mean there will definitely be ways of doing this. I mean, this is what this is about in many ways. to be able to make sure that you have no way of eavesdropping on any kind of data transmission, and keeping the data, keeping the keys secure, and using PSK. I mean, you have to use different methodologies, as mentioned before by one of the speakers as well, in order to to ensure that you have a safe environment that is to some aspects unbreakable. I mean, the chances of eavesdropping and not knowing that there's a problem when you use KKD is zero. As the professor in quantum physics was saying, from the Niels Bohr Institute, I mean, you have to break the law of nature, and so far nobody have been able to do that in his view, at least.
Can I do a very quick follow-up? Just a technical thing.
Go ahead, Manish.
Thank you. This is, do we know the nature of the flaw that was, that was utilized in order to get to the hacking, and whether it is a store now, like harvest now, decrypt later kind of?
No, it's not. I'm sure it's not. I'm sure it's not. I mean, right now, these are not the techniques, because you're not able to use this method at this point where you can literally solve the riddle as you go through the different pathways. That's simply impossible. So it's not done like that.
And there is a lot more questions with you in the chat, plus a few that are texting me in WhatsApp. Your presentation really made an impact. Also, quantum computing companies are actually texting me as well. So this is going to have a lot of follow-up. Stay with us, because the next presentation is something very relevant to you. We want to go to UK, and we want to present here, showcase here, a collaboration between an end user and a company that is supporting the end user in their dreams. Of course, I'm talking about British Telecom and Aegiq. Zoe, thank you very much for being with us today. Can you start? Can you kick off this fantastic collaboration presentation?
Yes, thank you. Thank you for the introduction. Can I just share my screen here?
Of course.
Yes, thank you. Okie dokie. Hopefully you can see that okay. So thank you for the introduction, and thank you also for the invite. So I'm very pleased to be able to speak today. So my name's Tom Lyons. I'm an engineer at Aegiq. We're a quantum computing and networking startup based in Sheffield in the UK. And over the last year, we've been working very closely with Zoe Davidson, who's on the call today from BC. And together, we'd just like to present some of the work we've been doing in an Innovate UK funded project, looking at physical layer monitoring and how we can use quantum technologies for physical layer monitoring on optical networks. So at this point, I'll hand over to Zoe.
Yeah, so I mean, obviously today we've heard quite a lot about PQC and QKD and the threat of quantum computers to our customers' future data and even their current data. One of the things that we're actually exploring as part of this project is actually the current lack of insights we have on our wider fiber optic network.
So I'm afraid we have a problem with your microphone, and I think, is there a way that you can lower the microphone or switch to a different microphone?
Yes. Is it too loud or too quiet?
It saturates, which means it's a bit difficult for people to keep their hearing at their top.
It's too loud.
Yes.
Is that any better?
I think it's a bit better. Try to keep the tone of your voice a bit low, and it should be fine.
Absolutely. Yeah, so we have an issue with currently have an issue with the lack of insights in our wider fiber optic networks and the impact of services. And this is just a selection of outages that we've had within the network over about the last year. Some of these have been related to fiber outages, but others related to other outages within the network. And you can see that they have very large knock-on effects. Small fiber cuts can isolate entire communities. And sometimes the headlines are very funny. Heads trimming mishap cuts off an entire village in Cornwall. But these are really important because it does isolate our communities from access to the internet and access to phone calls and various other things that they need to live their lives. But the other thing that is that by monitoring the fiber optic network more closely, we're also able to eliminate that as a problem earlier on in a fault finding process, so we can very quickly find out if the fault is in the physical layer or if it isn't. And that's one of the reasons that we've been working with Aegiq as part of this project. So next slide.
All right. Oh, I apologize. It doesn't want to change.
So keep entertaining us while Tom figures out how
yeah,
to go to the
absolutely.
slide.
Sorry about this.
So we have been working with both internally within BT. We'll be talking to our dashboard alarm creators, so understanding what useful dashboards look like and what useful alarming looks like within the network, but also to understand how we might use things like machine learning algorithms to analyze that data in ways that are useful to characterize faults within the network. And all of this kind of goes towards the quantum problem. You know, how do we actually protect our network and build our network to protect it against the growing quantum threat of quantum computers? So here we go. So this is yes, this is this is a similar slide to what we've already heard quite a few times today. So that quantum computing does pose this risk, and we do need to install things like PQC and QKD, or we need to look at them as solutions for our customers to keep our customers safe against harm. And there's multiple projects going on within BT to look at how we can implement both QKD and PQC within our network in various different ways, and how we can bridge the technology and how these technologies can be used. And QDAS sort of is a bridging technology that offers an insurance and an accelerated adoption by having a much simpler bit of equipment that we can use for fiber optic monitoring, looking at photon levels, but also looking at that quality of our fiber within the network. And then next slide, please, Tom. So we're currently monitoring the network by using things called SNMP traps, which are sent towards our systems. These monitor them, and we get dashboards that look very similar to the one on the right, which is basically a sort of a minimum level, which is that red line, and we get alerts based off our performance dropping below that minimal level, and that will then alert an engineer to go and fix the problem within the network. But this also does require a certain level of manual monitoring of the network. So we're also looking at how we can use machine learning to analyze this data in a way that makes sense for our engineers to spend less time manually looking at screens and more time out in the field fixing problems. So yeah, the summary from the BT point of view is that we need to roll out quantum safe technologies, and we're also going to need a new framework to ensure that we have this quality of service, and we're also going to need to put a lot of work into security and integration, and also the integrity of the services that we're providing, along with assurance.
Yeah, thanks very much, Zoe. So I apologize for that disruption, but anyway, we're back online now. Yeah, so as you heard from Zoe, BT are being very proactive and very forward-thinking in how they're going to adapt to these new quantum safe technologies coming on the scene, and how those things will change fiber optic networking and telecommunications in the future. But it's not just about challenges, and it's also about opportunities. And one of those, as Zoe mentioned in her first slide, was that there are inefficiencies and there are some issues with fiber networking today, such as outages, unexplained issues, maintenance problems, which are a problem today. And maybe we can use quantum technologies to help solve some of those problems now, without having to just be on this reactive footing to dealing with future threats of quantum. So these were the kind of discussions we were having with BT over the last year or two, and it was through those that we came up with the idea of the Quantum Link Assurance System, or QLAS for short. So in a nutshell, this is, as you can see on the screen, real-time fault detection and tamper-proof security for fiber networks. So there's these two parallel aims. The first one is really about Zoe's first slide, which is kind of maintenance and greater insight into the physical layer of your network. What's going on? Is all the equipment operating okay? What's going on with the fiber itself? Things like that. Are there any faults? Does anything need to be replaced? The second aspect of that is security, and particularly physical layer security. So is anyone tampering with the fiber, or is there any eavesdropping attacks, for example? And this is very relevant to what we've been talking about so far with QKD and so on. So for a little bit more information on the specifics, so we designed this product from the ground up to be fully interoperable and fully integrated with BT's workflows. So on the hardware perspective, all the hardware systems are server rack compatible enclosures, standard industry equipment inside, and standard fiber interfaces. So you can use this hardware to transmit quantum states into a fiber network and then measure them, and then extract from that information on the performance of the quantum link. On top of that, we've built a very full-featured API. This is using, again, industry standard tools, Apache Kafka for an API host, and InfluxDB, which is a time series database, which again is commonly used. And these things together handle the flow of this monitoring data, this performance data of your fiber network, your physical layer, and storing that in servers and then making it accessible to the end user, either through dashboards, which we've developed ourselves as part of the project, which can be used to present the information on what's going on in the network, or as we see it, which would be more commonly way to use it would be to have that API feeding directly into the network operations center of the end user, in this case BT. So this QLAS system would be one metric provider within all of the other metric providers that they have monitoring their network. So from a hardware perspective, again, with our focus on interoperability, we're using signals in the C-band, and we're multiplexing those signals into live fiber, or you can alternatively use dark fiber for a standalone kind of monitoring system. The software focus has always been integrating, so we can integrate here with this the NOC. So this is the Network Operations Center. You can see all the different metrics they have on their big screens. We envisage the QLAS system as offering an additional input into these monitoring systems. In terms of the project, as you can see here, we've developed a hardware prototype, which is this server rack box here. This was just assembled only a few weeks ago, and now we're kicking off the testing of the system and putting it through its paces. So in around a month's time, we will be deploying this on the BT network, which I'm very excited about. And we'll be using an extended deployment in the BT's network, and we'll also be attacking basically the system to see how well it performs about responding to changes on that fiber link. And we'll also be testing compatibility with core network architectures, metro network architectures, and all those small details that really will help a new product fit in to a market. So I've preempted the Optica question here on this final slide about how we can help each other. So from the Aegiq perspective, we are experts at quantum optical system development and prototyping. We're also more recently looking at a lot of quantum algorithm development as well. So besides telecoms, we're also a quantum computing company. So we're a testbed provider for the National Quantum Computing Centre in the UK. We'll be deploying a photonic quantum computer there in only 2 or 3 months from now. And we're also working with other partners such as the Royal Navy on quantum algorithms. What I would like to hear from people here is we're always looking for partnerships for validation of our new technologies, feasibility studies, things like that. We're interested in standardization and certification as well. But please do contact me if any of that is applicable. And Zoe, would you like to add anything on this slide?
I think very similar to what's been said by many of the other end users in this meeting, which is that we are looking at various products and ways that we can help our customers stay safe in a quantum future, and even now to protect them against future risks. So if you have those things, if you have those ideas and products, and you want to do collaborations and work that we can start to develop these things for our customers, please get in touch, and we'd love to hear from you.
Great. Zoe, Tom, this is a fascinating collaborative project. Thank you so much for preempting the Optica question. I look forward to checking back in to see the results from the trials. I believe there is a question from Bruno at Carousel Digital. Bruno, would you like to voice your question? Okay, so Bruno's asking. Oh, yeah.
One question. Is there any public specifications for QKD schemes to make sure that they're properly done? You know, when you open a scheme, to make sure that it's properly implemented?
To the best of my knowledge, I think this is what a lot of the standards bodies are working on at the moment, is to look at how we can standardize things like QKD implementations in a way that we can then certify them also. So this is work that BT is contributing towards as part of the ISO and the British Standards Institute as well. So that would probably be my best answer to that. I'm unfortunately not the most knowledgeable person in QKD at BT. There are many people within the company who know a lot more about it than I do. But that would be my sort of gut answer to that question.
Great, thanks. I just wanted to ask, do you see it being an issue distributing quantum keys over the sort of aging infrastructure? And is this collaboration addressing that?
Yeah, I'll handle that one. Potentially, yes. I think the fact that I don't have an immediate answer kind of tells you the story there that people don't really know. And so a big part of that is that BT and Zoe as well is involved in these kinds of test beds, deploying QKD systems, trying to understand how well they perform. And in the wider community, particularly with end users, as in people who use the network for communication, not the network operators, they have to try and learn how these systems work. Quantum key distribution, PQC, it's all like very complex and people have to adapt. And so one of the things we're doing with this product is trying to make it a smoother route to adopt these things, like a first step in the right direction almost. So also we've heard from, I think it was Jose who said earlier, like the risks are developing faster than the solutions. So there are things you can do today being 2025, with products such as QLAS, for example, that can be implemented in much nearer term than things like full-on QKD systems that maybe start to build into this defense in depth strategy without having to wait, potentially years for the full systems to come into play. And while you start exploring these novel systems like our one, it will help people get more comfortable with things like QKD, PQC, and it will help us understand exactly what you asked, John. How well does the network handle these new quantum technologies? Because it will be a learning experience for everybody.
Great. Thank you so much, Tom and Zoe, Aegiq and BT. If you can help with any of those things on that final slide, please get in touch with them directly or me, and I can put you in touch with them. So I'm going to introduce into the conversation now Optica corporate member Quantopticon. With us today, we have co-founder and chief scientific officer and director of Quantopticon Limited, Gabi Slavcheva. Gabi, welcome to the meeting. Please briefly share with us how your software can ultimately save the industry time and money by eliminating the need for repeated incremental experimental work.
Yes, thank you for your kind introduction. I'm going to share my screen.
That's the one, yeah.
Yeah. Right. I hope you can see my screen.
Perfect. Thank you. Yeah.
Yes, we're a software company developing simulation solutions for quantum photonic systems and devices with operations in Chicago, United States and Guildford, United Kingdom. We have created a quantum electrodynamic solver called Quantillion, which is dedicated to design and modeling and optimization of quantum photonic components, assemblies, and integrated circuits. And it's underpinned by a proprietary but patented algorithm, which has been developed by our team of world-leading experts over the course of 20 years. And we have experimentally proven and thoroughly validated our model and our software. So here are the active devices that we can model. We can model quantum light sources, single and entangled photon sources, both deterministic and probabilistic, optical quantum memories, qubits, for example, qubits based on neutral or charged excitons, spins, and so on. And in addition, we can model passive elements such as couplers, splitters, routers, gratings, which allows us to model the whole integrated circuit up to the detector. So basically, Quantillion provides a competitive edge to the quantum hardware developers in terms of maximizing the quantum performance of the devices, reducing the development costs, and compressing the prototyping cycle. For example, if we develop very high purity photons, we should be able to close the security loopholes in the QKD. For example, due to a vulnerability due to the photon number splitting attack. If we optimize and maximize the transmission of deterministic single photon sources, we can make faster secret key transmission rates. On the other hand, if we optimize and make very highly indistinguishable single photon sources, we can create quantum memory buffers, which will allow long distance entanglement distribution and on quantum networks. So here is a table which shows the main technological platforms that can be addressed with our software Quintillion. In terms of quantum light sources, we seek to speak to experts in solid-state architectures, integrated solid-state architectures, which are based on semiconductor quantum dots or vacancy centers in nano diamond or any defects in any materials, as well as rare earth doped waveguides and spin systems. So we have a long-standing collaboration with the European Space Agency, with the Technical University of Munich, with the Universities of Cambridge and Oxford, and the University of Chicago. And I also anticipated the questions about what we can do for each other. Basically, what we can provide is simulation and optimization capabilities in order to create optimized blueprint of a device. And on the other hand, we can also assess existing designs qualitatively or quantitatively. And also we can assess new materials and new quantum systems for bespoke quantum photonics applications. Thank you.
Gabby, thank you so much. You have many partners already. Is the software available for new industry partners to trial? And new software is sometimes time-consuming to integrate. What support is available when you use the software?
Right. We have already an MVP software, which is basically modeling of deterministic single photon sources embedded in micropillar geometries. This software is available, downloadable from our site, but we can help with the installation, and we also have we can help with setting up simulations by our users. We have dedicated people that can help with this. Our other software is under development, which we hope that we will finalize very soon, and we'll be able to model also probabilistic single photon sources.
Great. Thank you so much, Gabi Slavcheva from Quantopticon. Please do get in touch with them or me, and I can put you in touch with them. Let's move on. We have Ahmad Attia here from OptiWave, the sponsor, one of the sponsors of the meeting. He's the Vice President of Optical Systems. Please tell us how your suite of products can help quantum communications.
Thanks, John, and hello, everyone. Let me share. I have one slide here and share it. Okay, so OptiWave basically a software developing company. We offer different packages of software which can be used to design devices, subsystems, and optical communication systems, as well as for the sake of this meeting is for designing quantum key distribution and for quantum communication. So the main package, as you can see here from these different packages, is OptiSystem and OptiSpice, where you can, in OptiSpice design, photonic integrated circuits can be used for your specific design in the quantum regime. And OptiSystem, which can be integrating these devices into a system and then can be characterized. So in OptiSystem, we have over than 610 components and visualizers like instruments, which can be used for visualizing and designing the communication systems and the quantum systems, as it can show you in a few minutes. The other part of it is also OptiSystem is able to interwork with other software external packages like Python, MATLAB, Scilab, as well as also we are integrating with Photonic Integrated Designer from Lucida, Aegiq software. So you can take these designs and integrate them in our software and then characterize them. In terms of quantum key distribution, the software is able to design or enable support the designs of different quantum communication key distribution systems. So we have different components, as you here see sample of these 610 components. We have single photon lasers, single photon detectors, photon number resolving detectors. We have different channels to try your transmission of these quantum key distribution schemes into the different channels, either fiber, single mode or multi-mode, multi-core, free space optic channels, underwater channels, as well as different components for randomly selecting switches and select devices, so you can run them into the design system. And also we have an instrument which can measure the polarization per pulse. So if you send stream of pulses and every pulse has different polarization, you should be able to monitor the polarization state per pulse, per photon, basically. The other thing is here, for example, an example implemented in Opti system software for PP84 quantum key distribution algorithm using the different components I'm mentioning here. In Opti system, there is over than 1,000 examples, which can guide you for designing your system in different applications. And if you want to download our software, you can go to OptiWave website. You can download any of these 8 software packages freely for 30 days to try them. You need to register on our website, and then you can download the software. If you need any question, please don't hesitate to, or you need a demo of the software and the capability, please contact me at optiwave.com. Thanks, John.
Ahmad, thank you so much for your support to Optica. Please do get in touch with Ahmad or OptiWave to trial their products. So we now come to the part of the meeting where we're at the intersection of fiber-based QKD and free space and satellite QKD. Costantino Agnesi, co-founder, scientist, and product developer at meeting sponsor ThinkQuantum. As a member of the recently formed multi-vendor ecosystem for quantum safe communications, please tell us how you, through this ecosystem, are accelerating adoption of this technology across the various network configurations.
Hello to everybody. I hope you can hear me. I'm Costantino Agnesi, co-founder of ThinkQuantum, and I hope you see my screen. And if you see my screen, you should see in the middle of it a figure. This picture is basically the vision that we have here in ThinkQuantum of how the future communication networks will look like. And in these communication networks, quantum communication will play a fundamental role, not only in keeping our communication safe through quantum key distribution, but also interconnecting our quantum computers and quantum sensors to allow them perform tasks that we never thought possible. And as you can see, there are different nodes in this communication network. And each communication network can connect to each other in diverse ways. For example, it can be through fiber links, it could be through free space links, or it could even be through satellite links. And this is where we see ThinkQuantum enter the picture. We find ourselves as providers of flexible quantum communication solutions that enable this vision. And more or less, we would also want to do what we're doing in this meeting, basically bridging the terrestrial networks with the satellite-based networks. So how are we doing this? We're doing this by, for now, providing quantum key distribution systems that are perfectly flexible to work both in fiber connections and also free space connections. And this is where our cookie platform enters the picture. Apart from being flexible, and this is due to its polarization encoding, it also has an integrated quantum random number generator that we provide, that we develop ourselves, the ThinkQuantum, that gives us a stream of random numbers, and each qubit that we emit is basically encoded according to a random number from our quantum random number generator. The flexibility of our cookie platform does not stop there. It also is a great tool for networking solutions. So we talked a bit about the software-defined networks. Our systems are fully compatible with the ETSI standards for SDN, and basically they allow for the development of complex quantum communication network topologies by using less hardware. Lastly, we are also working quite actively in the space domain. So we are both working on the ground with our ground stations, making them ready for the communication requirements of QKD, but also actively in the development and the qualification of our sources to be able to take our cookie platform not only in a terrestrial scenario, but also for a satellite scenario. So let me finish by answering the Optica question. We're not just your partners, not just your providers. We're your partners in building the future communication networks. Whether you need a turnkey quantum communication solutions, like our commercially available cookie or thick platforms, which are designed for immediate deployment, we can also collaborate on developing novel quantum technologies, since our team is thriving in co-innovation, and it will help us basically bridge the gap between today's challenges and tomorrow's quantum communication networks.
Costantino, thank you so much for your support to Optica. I will be very, very happy to put you in touch with ThinkQuantum and Costantino, so please do let me know or get in touch directly. We're very pleased to invite Airbus back to one of our meetings now, following the Quantum Industry Summit in Bristol. They are, of course, pioneers of sustainable aerospace. Johanna Sepulveda is a senior expert on quantum secured communications and chief engineer in a forward-thinking organization who have been delivering post-quantum cryptography solutions since 2017. Johanna, welcome from the UK to Germany. The floor and the attention of everyone is yours.
Good afternoon, and thank you so much for the invitation. It's a pleasure to present you the footprint of Airbus. So as you know, Airbus is an integrator. Usually Airbus you can recognize as leaders of the aerospace segment, and you can easily identify us by our commercial aircrafts and helicopters. But also Airbus, it is leader on the defense area, providing secure communication solutions to different governments in Europe and outside Europe. So quantum technologies is reshaping different market sectors, and of course, it also has a huge impact in defense. And this was already recognized by different nations, and that is why quantum it is also used in the defense area. We know the impact on the different pillars, and of course on the quantum secure communication. So together with our customers, Airbus is integrating and exploring the different quantum secure solution in order to shape this quantum safe world. So we have different challenges in the defense area. So first of all, defense is characterized by the requirement of long-term security. In addition, we have different levels of criticality. That means that we have to face different security levels. The devices are heterogeneous. They not only are deployed in different domains with different environmental constraints, but also with different processing and communication capabilities, protocols. And on top of this very challenging environment, we have to include quantum secure communication. Our customers are aware, and they are really requiring these quantum secure solutions. And they need both, not only post-quantum crypto, but also quantum communication. And that is why they want to explore and see what are the main features and how they can use in order to provide their secure connectivity. It is clear that for a customer, they want, when they require quantum, when they require secure communication, they don't care about which communication or which technology is underlined while meeting the requirements. Nevertheless, it was widely accepted that this transition towards a quantum secure communication will be carried in a layer approach. So that means that traditional security on top of post-quantum crypto layer, and for certain applications such as critical infrastructures, governmental information, as well as for finance, an additional layer of quantum is required. So we know about the huge evolution of the post-quantum cryptography that has come up with a standard. One thing that we can learn for this post-quantum world is how the different communities work together in order to make it feasible. And Airbus is working since several years ago in order to integrate this post-quantum technology in the different defense applications. So the Airbus, and we are very proud to be pioneers not only on the implementation of post-quantum cryptography, but also in the integration in the different applications, being the pioneer, for example, of the co-design, being that means the partition between hardware and software on post-quantum solutions, being the designer of the first European chip with post-quantum capabilities, and also being leader of different demonstrators with these kind of technologies. We also are combining both technologies, post-quantum and quantum technologies. Regarding quantum technologies, we already have seen all the different properties that they have and how it is very relevant not only to include this terrestrial but space segment in order to get the best of both worlds, the throughput and the fast key exchange together with the wide coverage of space. And for that, for us as Airbus, it is very relevant to work with different partners in order to integrate such technologies in these segments. Our customers are also interested in that. That is why Airbus has been contracted in order to design the European quantum communication infrastructure in the terrestrial and space segment. So the European Commission, together with the European Space Agency, are developing these two segments in order to build the secure communication infrastructure in Europe. So Airbus has designed the end-to-end architecture. Also, we are participating in the part of the demonstration of the French national network. So since 2 years ago, the European Commission is supporting the deployment of these quantum networks in all the European countries. And also we are supporting the part of the coordination and leading the discussions of interoperability among the different nations, as well as the standardization requirements. In the part of space, Airbus is designing the space backbone for quantum for Europe, as well as it is the supplier of the optical ground station with quantum capabilities. And take into account that this is expected to work together in the future with IRIS². But it's not only the European Commission and the Space Agency, but also different defense areas are investing on designing the quantum network for the military area, and Airbus is the designer of it. In the part of space, as I mentioned before, Airbus is bringing together the QKD into the optical ground station in order to enable also this kind of space communication. It is not only necessary and very relevant, the design of this backbone and the integration of this physical layer in the terrestrial space and in the future in airborne capabilities, but we also see a very relevant role and also concern in the part of the secure integration and interoperability of this new physical layer, that is the quantum layer, into the overall communication and secure infrastructure. So for doing that, it is required a set of different building blocks that enable the secure interoperability of this new technology. Currently, also, Airbus has innovation in the part of quantum communication. So usually, for example, we can identify in order to integrate this new layer of optics and quantum into the communication infrastructure. It is identify different layers, network layers, such as the key management layer, the SDN of control layer, the management plane, etc. And usually, for example, the key management is employed in a distributed way. Nevertheless, you have to be aware that when you have the distributed part, you need to ensure that the trusted node is trusted. That means that you have this strong security perimeter with a strong security requirements. Maybe it is, yes, it is an option widely adopted, but is this the best? Maybe not. So that is why Airbus also proposed innovation in order to use and to take advantage of the quantum layer in the best way possible, relaxing this security constraint that currently are very tight in the trusted nodes, and using this quantum material in a better and enhanced way. For more information, you can visit our public article in the Airbus website. The advantage of the solution is that it relaxes the security requirements of the trusted nodes. So please don't forget to visit it. And if you have any question, we are very happy to answer you. And in the future, we see a future very bright. We know that these technologies can be further embedded, for example, in hubs or drones for enhancing the service provision of quantum. And we will be there for providing this technology. Thank you.
Thank you very much, Joanna. I'm a huge fan of you. You do a fantastic job together, not only with Airbus, but also with your role linked to the European Commission. It is really great to have you on board with us at Optica. Extremely happy. Could you share with us one challenge, just one challenge that you found today you will go to sleep very happy?
So the challenge, it is the multi-domain working together, because in order to make this possible, it is not only required all the fantastic know-how of our physicists, but we need that these physicists work together with the cryptographers, with the application engineers, communication engineers, in order to bring this together to the customer. So working together is mandatory. Interoperability is also mandatory, more so if we use, when we talk, for example, on this European kind of connectivity where different countries must be work together. Backbones in this solution in the terrestrial part are not recommended due to security level. So we need to know how different nations with different security policies can also work together in this kind of mega networks.
When it comes to real world demonstrations, I really admire what you are doing today. Let me bring to the table one person that I think has also something to say when it comes to real world demonstrators. I'm here with the founder of memQ, Manish Singh. Manish, thank you very much for joining the meeting today. We just heard the presentation from Joanna. We're about to hear the presentation from Kasia from the European Space Agency. Be the link between these two. Tell us what you can do for others and others can do for you. Manish, are you with us? I think you might be on mute. Yes, hi.
Could you confirm that you can see my slides still?
Gorilla Glass Clear.
Okay, great. Thank you very much. All of you have already heard about the importance of quantum memory in enabling quantum networks from the speakers who came ahead of me. A lot of work that is happening in quantum communication and networking today, it's point-to-point based. And we see it evolving to a point where we have large quantum systems that are made up of quantum communication nodes, compute nodes, and quantum sensing nodes. If we take the quantum computing industry, for example, the industry has coalesced around the vision of modular quantum computers. These small modules need to be networked together to get to a point where it can help us tackle some of our most challenging problems as humanity. And at memQ, what we are doing is we're leveraging our rare earth qubits platform to build scalable quantum memory devices that operate at telecom wavelengths. And we believe that these are key for these network quantum systems. What we are doing is we are monolithically integrating erbium ions with commercial foundry photonic integrated circuits. and using these to develop single photon emitters, memories, and routing capabilities on a low loss platform. When it comes to quantum, loss is a killer. And by bringing everything together, we are hoping to solve that problem. Our longer term vision is to integrate all these capabilities together and use multiplex memory along with routing and detection capabilities to enable large scale quantum information routing. And this is how we are doing it. After intense internal development, we are very happy to share today that we have hopped ahead in maturity by directly integrating our qubit layer with commercial foundry chips. What you see here is a 300 millimeter wafer, a tape out that received about 5 months ago. In here are our designs for quantum memory, for single emitters, and the way we take advantage of this commercial foundry offerings is by opening up windows so we can do backend processing where we are adding the qubit layer on top of these very low loss waveguides, very high performing interfaces. That's on the second figure here, where you're seeing our proprietary material layer that goes in there, like adds the access to the erbium qubits that serve as the memory layer. And with that, we have been able to demonstrate really high quality, high per cell factor. We have shown very high engineerability at 2 wavelengths that are of interest, that are compatible with the telecom C-band. That's at the 1520 and 1533 nanometer wavelengths. And what you see at the bottom in blue, that's our prototype for our quantum memory and quantum single photon emitters. These are the best part about this is an optical I/O. So all you have to do is you can plug it into your standard devices and you're able to interact with it almost right away. So we're very excited about the paths that we are following. We're very excited about the capabilities that we are bringing to the industry. And I would ask you to please reach out if the way we are solving this problem, it solves this problem for you, or if you're interested in working with us on these technologies.
Thank you very much for a great presentation, Manish. It is great to see what you're doing on the real world. And it is also great to see how you're collaborating with different companies to upscale and really show real life demonstrations. Manish, I'm going to come back to you a bit later, but I want you and Joanna to continue in the meeting to listen to the presentation of a really close person to Optica. For many years, he's been speaking at our events, talking to our members, engaging one of the master of collaborations. She's talking to us today, representing European Space Agency. Katarzyna Balakier-Kasia, thank you very much for being with us today. Tell us what you bring to the table from European Space Agency, and most important, how can we help you being even greater than you already are? The floor is yours.
My talk is really to give a little bit of highlights and explanation of how we leverage space and use space as well in the context of quantum communication. And to do that, we very much work with industry and for industry. We created a strategic program line called Skylight, which is looking directly at optical and quantum communication. And in this area, we prioritize 3 pillars, I'm going to call them. So free space optical communication, we have been recently having great successes on intersatellite links, cross-atmospheric communication, and as well the buildup of the high-throughput optical network, so very much extension of the backbone fiber networks to the sky. We also work on photonics in the context of new photonics devices, but also on-board connectivity, on-board of the satellites connectivity, and finally the quantum communication. And in that context, we support both QKD, so that is our lower hanging fruit, we are going to call it, as well as the expansion towards quantum information network, and as well as some of the missions that I can highlight is the mission of SAGA to demonstrate the QKD which is the space segment of EuroQCI as well. So supporting the first applications or the first operations of the EuroQCI extensions to space. In the area of ESA strategy, and I can see that my slide is not progressing. Yeah, that's the good one. In the context of ESA strategy for quantum communication, we've put a lot of focus on aligning and working with multiple or all the countries which are ESA member states, aligning their national strategies with ESA strategy and working together in creating those future quantum communication networks. For quantum in space, we build a lot on the successes of the optical satellite communication. So we leverage on technology developed for optical SATCOM, and also ensuring that transfer of knowledge, transfer of technology between optical to quantum, but as well particularly in the quantum area between academia and industry. We support multiple QKD missions. We are going to have some launches, including end of this year and the beginning of next year. Those are at the moment the technology demonstrators. I won't be able to, with some of them showing as well the first applications. I won't be able to go into details of all of them, but I know that after that, Andrew will present a very good example of the partnership between ESA and industry. So we look at the QKD for both commercial applications as well as institutional applications. And what is very important at that stage for QKD in context of satellite are those first demonstrations. I think that things will develop much faster after we have those first QKD demonstrations. And the next one is a little bit looking towards the future, is the quantum information network. So very much shifting from the QKD prepare and measure towards the entanglement-based solutions. And in the context of QKD and in general of what is happening in the area of terrestrial quantum communication, we have seen fantastic first demonstrations, and we from ESA really look at how can we support and complement those demonstrations with satellites by providing this long distance communication, by increasing the resilience of the quantum communication, by adding that satellite layer, right? So those are our current objectives and where we are going at the moment. So moving towards the longer distances, how can we communicate across the continent? How can we communicate in quantum domain between the countries? And for the QIN, so entanglement-based quantum information networks, what is really important are the in-orbit demonstrations as well, those first in-orbit demonstrations and the development of the ground stations. Jose, have I lost my slides?
Let me pull them back.
You have lost your slides, but we have
I have lost my slides.
My team is gonna share them from our side, so we wouldn't.
All right. So while
you're doing great. So please continue.
You can still hear me. So yes, if you could add that back in and perhaps move to the next slide, where we indeed look at quantum communication as well from the application perspective. So on the left-hand side is the quantum COMMS for secure communication. This is what we are already developing. We are fairly high at the TRL levels. But we want to really move towards the future and creating those quantum information networks, for example, for distributed quantum computing, for quantum metrology, for distributed quantum sensing. This is the new area that we try to open, the new applications that we will try to enable by creating those quantum information networks with satellites, right? So that is where we currently try to develop more work. We have recently fantastic applications from industry exactly in that area, and it's going to be a topic of the discussion for the next months and the next years. And that is my almost last slide. At the very last slide, I just would like to say, if you would like to work with us, or many of you, I've recognized so many names already, please get in touch. And if the quantum satellite networks are of interest for you as well, ESA is organizing a workshop to discuss that further with industry. So I hope the industry members, but as well academia, but as well Optica, will come and join us in that discussion. Excellent, thank you.
Great, sounds fantastic, Kasia, and it's all incredibly exciting. Thank you for your talk. It's my great pleasure now to introduce our final keynote speaker of the meeting, Andrew Sisma. So Andrew is the Senior Director of Business Development for Space at Honeywell Aerospace Technologies. In this role, he focuses on advancing Honeywell's satellite and ground-based optical and quantum communication solutions. Honeywell recently announced a public-private partnership with ESA to provide their trusted node QKD-SAT, an ultra-secure telecommunications satellite that helps keep the exchange of sensitive information secure and private. In the quantum space as well, Honeywell is the majority shareholder in trapped ion quantum computing company Continuum. Andrew, again from the UK to Canada, the floor and the attention of everyone is yours.
Thank you. Yeah, thanks, John. Thanks for the time with everyone here. Can everyone see my slide okay?
Yes.
All right, great. So yeah, I'll step through a little bit on Honeywell abroad, and then get more into the details on what we're doing in quantum security, and specifically on the QKD and the satellite-based solutions. So before I dive in, just Honeywell overall, we are a very large multinational organization. So we're about a $35 billion annual business that we kind of run through. We have basically about 100,000 employees globally, but if you take a step back, it really comes down to a couple pillars, aerospace technology. So this is defense as well as aero and space that all resides underneath this. Building automations and industry automations. This is really about us protecting and connecting, globally all the commercial solutions. So we're plugged into about 10 million buildings worldwide, control and provide services around that. And then there's the energy and sustainability part of the business, which is really more about creating critical infrastructures, both energy and evolution in terms of like oil and gas, in terms of how this goes through. But when you take a look at this, it's really layered with a connected enterprise. It's how we provide solutions to our customers and how we enable this. And this really comes back to security and cybersecurity that is the foundation to all of this. So we provide technology from a hardware perspective, but then really digitally to enable the services part of this. This is really what's the foundation to the overall business. And that's really what we look at quantum networks. So if you start looking at, we've had a lot of conversations about the threat about quantum computing. We got the great privilege to actually work in all three pillars. We do quantum computing, as mentioned, with Quantinuum. We do quantum sensing abroad, and now we're really quantum communications, which is what this focuses on here. But recognizing that it's a question of when, it's not a question of if in our minds, when you're going to actually have threats to your networks and your digital infrastructure. So as a result of it, the foundation, you need to have a quantum safe network to kind of move forward. And we really see this as a pillar within the next 5 years that is absolutely critical to have. But then really building upon this and where this goes is how do you actually have now quantum networks and then eventually into the quantum internet. This is where the security, distributed timing, distributed computing, all these applications start to become. But the foundations of how satellites kind of work with terrestrial networks is key. And that's where we really focus in on the first step being this QKD and hybrid kind of network with PQC in terms of making sure you got a quantum safe application to then build these other applications as they come available to the overall globe and the net market. So for us, what we've been working on for quite some time now is we're prime on a KeySat mission with the Canadian Space Agency, and more recently with the ESA that we're actually working on board about these demonstrations. So this is actually post CDR. It's actually, we have spacecraft built, qualifications completed, we're building flight units, and it's really going to be launched deployed next year. This is the foundation to actually allow us to kind of connect globally how we do demonstrations and get this adoption moving forward, and really key in terms of how these networks are going to operate. And that's why this demonstration mission is so critical, because it allows us to play with these different parameters. Next, I would say is really with QKDSat and the PPP approach we have with ESA, it's about commercial. This is really about deploying out how we demonstrate a commercial operational system, you know, in the 27 kind of time period as we see these threats really occurring. So it gives us two levers: demonstrate first, commercially roll out and implement these changes as required. And that's really why we have multiple ground stations and solutions. Some that are fixed assets, some that are mobile assets. But it's really to demonstrate how these networks are going to operate and then really implement the actual full-scale kind of commercial solutions that we see that would be after that. And that's really where the advent of scale and then adoption really comes in our minds. But our approach is work with governments very closely, work with industry very closely, work with commercial partners very closely, and then really get that adoption and scale, which is really, you know, the foundation of what we have as our last kind of slide here. So for us, it's about partnerships. And these events are fantastic kind of connect into the different partnerships. But we really have to have a terrestrial and space-based end-to-end quantum safe networks. This isn't going to be implemented by one organization or one company. It's going to be about the collaboration of how this gets pulled together and get adopted in terms of an overall solution that's required. But it is the foundation of a quantum safe network that's required for our digital economy now, but also what quantum networkings are going to look like into the future. And we feel like we're at this forefront that we're able to make these demonstrations and looking for partners to do these demonstrations with, also getting the adoption in terms of commercially where this kind of goes through. Collaborations with the governments, ESA, CSA, and beyond are foundational for us, but then really it's about industry adoption next. And that's really, if I was to answer the one question of what we need, it's that commercial adoption and that kind of push. There's a lot going on in industry. There's a lot of kind of conversations today that have been happening, but really we want to be that glue that enables us to kind of connect something that is foundational for what we see now and into the future, and then scale it to what we actually see as really where this could go into the future that will be quantum safe infrastructure, but quantum safe networks in the next decade. And I think that's the last slide, John. Any questions, I'm happy to take them now.
See, yeah, we have one question. The first question is, Honeywell is a giant in the industry, one of the key companies in the ecosystem. If you look at optics and photonics in any application field, you're always leading. In quantum, you have been taking the lead on this and you're looking for partners. Could you specify on the technology side one challenge that the Optica corporate members could help Honeywell with?
Yeah, so I say on the technology side, this is really about, you know, standards, I would say, across the globe. You know, we're multinational and we're really starting to see these different standards in different locations and how we actually come together to ensure interoperability between allied countries. To us is, you know, that's the key, right? That's what really allows the scale to kind of happen next. Technically, there's lots, right? There's evolution. If I look at today's problem statement and then tomorrow's problem statements, there's still lots of evolutions in, you know, quantum memories and other, you know, innovations are required to really get to that quantum networks and quantum internet of the future. But today, I would say first is really the adoption of quantum safe networks. It's those standards and seeing one, you know, common approach that we can really take to industry.
You're going to see many of your colleagues next week in San Francisco. Andrew, stay with us, but allow me to close the meeting for the people watching in YouTube, because this has been, in my opinion, a very, very, very interesting and important discussion. Let me, if I can ask my team to stop sharing the slides of Honeywell. Yes, thank you so much, everyone, for being here. For those of you who want to stay for a follow-up discussion, you can stay. And for those of you who have to go, thank you for making our dreams come true.